video is going to go over number 30 from 11.1 and number 33 from 11.2. Before we get to that, I just want to kind of review the methodology behind proving something. So we can kind of think of it as if you want, as a treasure map. I know I've used Easter eggs already, so I don't want to use that analogy again. But if you have a map, right, and you know where you are, let's say you're here, and you know where you want to go. So this is kind of the given. You're the given, and where you want to go, or X marks the spot, is where you want to end up or what you want to prove. You have to figure out what's the best way to get there, right? So if you're looking at, let's look at number 30 from 11.1. We are given that MIS is a right triangle with altitude IT, and we are also given that MI equals TS. So we're going to start with the first given, right? So we're starting here basically. Triangle at MIS RT is a right triangle with altitude IT. So with what we're given, you can kind of think of it like you're standing here and you can see a certain amount of distance, right? And so you're going to pick whichever way you think is best. So let's say there's like a mountain range here or something. You can't see over the mountain range, so you can't see past it, but you can see what might be the easiest way to get through. So you're going to pick a certain direction to go. It might end up being the wrong direction, and so you have to go back and you have to choose a different direction. But we're going to look at this and we're going to see what we can get from what we're given. And so if you have a right triangle with a certain altitude, it should make you think of Theorem 62 and all the corollaries. So if we turn to page 391, we have Theorem 62 and all the corollaries, or if you turn to the back of your book, that's all given there too. And so we can look and we can see that, so where we want to go is, sorry, I forgot to say that. Where we want to go is that MT over TS equals TS over MS. So the reason that knowing where you want to go is important, because if I didn't know that X was over here, I might go that way, which is the opposite direction of where we want to go. So we know that we want to get something proportional here, and we can look at this and see that TS is the same as TS, so we have a geometric mean. So that's another giveaway why we will need to use Theorem 62, but we want MT and MS to match up with the theorem or corollary we're going to use. So if we look at MS and MT on number 32, or sorry, 30, we see MS is this whole distance here, and MT is this distance here. So we're going to look at the theorem and see which one is the best. We're going to go with corollary 2 because each leg of the right triangle is the geometric mean between the hypotenuse and its projection onto on the hypotenuse. So that tells us that MT and sorry, I'm flipping back and forth. MT over MI equals MI over MS. That's Theorem 62, corollary 2. And these are obviously not the same, but it's close. We have MT and MS, but we have TS here and MI here, same thing here. And if we look up, we see that MI equals TS, so we're going to use that given, MI. So this is like getting over the mountains, right? Over the mountains. So now we're here. And so we're going to see, this is like the next given. And from this given, we're going to see what's the best path. MI equals TS given. And that just fits in well with what we learned before. TS equals, TS over MS. And that is what we're trying to prove, and this is just substitution. So there you go. Quick 4-step process for number 30. All right. For 33, we're going to do 11.2, number 33. And we want to do the same type of idea. We're going to take the given, we're going to see where we can get with it, and then we are going to take the next given. Oh, we're not given another given. But we're going to see, once we're done with that, what we might be able to find next. So we are given, I'm just going to draw this really quick. BAN D. So we're told that all these triangles are right triangles. So we're given, so again, we're going to start with the given DBA, triangle DAN, and triangle DBN are all right triangles. That's given. All right, so what do we know about right triangles? One thing is we know that all these are similar, right? So we could go with that. But if we look at what we want to prove, what we want to prove is BA squared plus 2DA squared plus AN squared equals BN squared. So what do we know about right triangles and equations like this where there's a squared plus a squared plus a squared equals a squared? What you should think about is Pythagorean's theorem, right? We're told a squared plus b squared equals c squared. So since this is where we want to go, so we're starting here and we want to go here, we're probably going to take the Pythagorean theorem route and not this similar triangle route. So I'm going to say dA squared plus BA squared equals BD squared. So the reason I chose this order is the hypotenuse is this, and so it's the leg squared plus the leg squared equals the hypotenuse. And so I'm going to do the same thing with DBN. So I'm going to say BD squared plus DA squared equals BN squared. And then finally with DAN, so DA squared plus AN squared equals DN squared. So, we do not need all of these. I just wrote them all out so we can see what we actually need. So we're going to use some type of combination of these three to get this down here. So I'm going to look at this and I'm going to see, I see BA squared and DA squared. So I'm probably going to use this one, right? So I'm going to take BA squared plus DA squared, and I need another plus DA squared and AN squared. So I'm going to do so I did this one, and I'm going to use this one, plus DA squared plus AN squared equals BD squared plus dn squared. So I had to combine these two right here. And this is just addition. Okay, so this is not quite the same as this, but what I can see is that this, where have I seen this before? And I'll look up here and I see it right here. So I'm just going to use some substitution to get my bn in for here. ba squared plus da squared, 2da, because we're adding da squared plus da squared, so we're doing it twice, so 2 times da squared plus an squared equals, and then I'm just subbing dn for dn squared for bd squared plus da squared, which we found here. Oh, sorry. That's not the same, is it? Which triangle is this? This is Dan. dA squared. Oh, I did the wrong one here. So bn squared is going to be bd squared plus dn. So yeah, this should be an n. Okay, now we're good. So subbing this in for this, which we found here, so we're going to get bn squared, and we just use substitution. And there we go. That's just a quick 4-step process for proving number 33. So again, you're given a given, you're going to see what you think is the best way to get to the proof, and that's the route you're going to choose. And you're just going to take your first step, stop, look, next step, stop, look, next step, and then hopefully you get to where you always want to go. But always have your final step in mind when you're stopping and looking ahead.